Parmenides' most famous student is Zeno of Elea. And unlike many philosophers who have students, the student in this case did not reject the main claims of his teacher, but instead provided new arguments for Parmenides' theses, especially the idea that there is no motion and that all is one. Before we get into the arguments of Zeno, I just wanted to do a quick review. You can skip forward a minute or so here if you're familiar with reductio ad absurdum arguments, but here's just an example of how these work, because this is the main way that Zeno argues. So what we do here is consider something. So we'll just lay out the parameters of the discussion, consider x, and x is not 0. So we have that clarified. And then a reductio always has a supposition. So suppose something is true. In this case, we suppose x is divided by 0. That's possible, that results in some well-defined quantity. We'll call that y. And so in other words, we're supposing that you could divide by 0. Suppose x divided by 0 equals y, and y is a well-defined quantity. In that case, if x divided by 0 equals y, then x equals 0 times y. And it's a principle of multiplication that 0 times anything, including y, equals 0. But that means that x equals 0. But remember, we started with the parameter that x is not 0. So 5 contradicts number 1. The supposition has led to a contradiction, and that means one cannot divide by 0. So we suppose the opposite of what we want to prove. In this case, we suppose you can divide by 0, and we prove that you cannot divide by 0. In the case of Zeno, this is his first and most famous argument. So when people talk about Zeno's paradox, they're primarily referring to the argument we're going to talk through here. And there are even comic strips that have talked about it. Zeno having this great excuse for not showing up at work one day. In any case, that may make sense after we cover this. All right, suppose that something is in motion. All right, so this is the supposition that's going to lead to a contradiction or an absurdity, and thus where we will end is with the conclusion that there is no motion. Okay, but suppose something is in motion, so it goes from point A to point B. So we have this simple movement from one point to another, and to get to B from A, it must first get to the halfway point between A and B. So we have this distance between A and B, we have a halfway point marked there, and we can call that halfway point C. Okay, so if it's going to go from A to B, it has to go through C. So it has to first get to C. But then to get to C, we'll just magnify this left portion of what we have in 2 diagrammed. And to get to C, it must first get to the halfway point between A and C. So we'll magnify that. We'll have A and C. There's a distance that it has to travel there. And so we'll call that midpoint D in this case. Now, hopefully at this point you can see that we're going to get into a problem, because this can be repeated to infinity. And so there are an infinite number of points that one must travel to go from A to B. Any point A to any point B. Any motion whatsoever, in other words. So the problem is, rather, that it's impossible to actually traverse an infinite distance. It's impossible to traverse an infinity. And the supposition of motion then that we started with in 1 leads to this impossibility in 5. And so we can conclude that nothing can move. There is no motion. Another way that Zeno argued this thesis that there's no motion is by talking about Achilles, shown here, and the tortoise. And the idea is that suppose the tortoise is in motion. So we have Franklin, the tortoise here, and we're going to suppose he's in motion. And if the tortoise is ahead, and we'll make this a counterclockwise race and around the screen, and the tortoise is ahead, so there's this distance between Achilles and the tortoise, and we can just call that distance d. And so the tortoise moves, and Achilles moves, right? The tortoise has the head start, but by the time Achilles traverses d, the tortoise will be in a new position. Right? The tortoise isn't going to be at d anymore because it's moving, it's in motion, it's got a head start. So by the time Achilles gets to where the tortoise was, Achilles will have to traverse a new distance between himself and the tortoise, and we can call that e. So tortoise keeps moving, and by the time that Achilles traverses e, the tortoise will have moved, so there's going to be a new distance to traverse, and the tortoise is ahead, and either Achilles could never catch the tortoise, or motion is impossible, or both. You see that the distance here has been decreased, but again, by the time Achilles gets to where the tortoise is still in motion, and so there's still going to be more distance to go. So even though the tortoise, the tortoise is in motion, Achilles can get really close, but you could never actually catch the tortoise. And so motion is impossible. Another concern about motion for Zeno is the idea of an arrow being in flight. And he says, actually, when you say that an arrow is in flight, it's really not in motion if you think about it. So suppose an arrow is in motion. I mean, we'll just suppose people are right and arrows can fly. So we have the arrow moving, but at any point in time, it must occupy a particular space. At any given time, it's in that particular space. But whenever something is occupying a particular space, it's not in motion at that time. It's just at that single space. And so at all times, the arrow cannot be in motion. Any given point in time, it's not in motion. So again, motion would be impossible. Zeno also argued against plurality, and one of the main arguments against plurality goes like this. So whatever exists has size or magnitude. And what has magnitude, right, a size of some kind, can be divided into proper parts that exist. So if something is an inch in diameter, well, it could be divided into something that's a ½ inch wide. And so if anything exists, if X exists, it has parts, and then we'll just identify any given part of X as Y. So let's just say Y is a part of X. So that means Y exists, and then of course Y has size, it also has magnitude. So Y has parts, and then we could identify any given part of Y, we could call that Z. So Z is going to be a part of Y, and of course that means that Z exists and Z has parts. And we could treat these steps like shampoo. At least it used to be the case that all shampoo bottles would have this direction on them: rinse, lather, rinse, repeat, right? And the idea is if you follow directions to the letter, you're going to run out of shampoo, right? There's no stopping point, in other words, and there's certainly no stopping point to identifying parts if we're doing it in this way. So X has infinitely many parts. But that would mean, says Zeno, that X is infinitely large. If it has infinitely many parts, it has to be infinitely large. And if X is infinitely large, then nothing else could exist. Right? There's no room for anything else. It's all X. It's all one, which means there is no plurality. And when we think about the previous argument, somebody might say, well, maybe it's not consistent with physics, this discussion of parts that are divisible. But the argument is actually consistent with physics no matter what. Whatever exists is composed of units with magnitude. Either these things, the parts, have units of magnitude, or maybe it exists with units with no magnitude whatsoever. But if the components, the parts that have units that have magnitude, then the above argument works, right? As is. The argument against plurality, that was the assumption, so it works as it is. But on the other hand, if there's no magnitude in the units, then no number of them can form an object with magnitude, right? 0 plus 0 plus 0 doesn't matter how many zeros you have, you don't get anything from it. And the universe itself is without magnitude, and in that case, there's no plurality. Zeno also argues against plurality by considering millet seeds. And he says, suppose there are many millet seeds. Suppose a bushel full, of a large basket full of millet seeds. And if that's dropped, if you drop this very large basket, it'll make a sound, certainly. But suppose only one seed is dropped, Zeno considers. Or we might even say, suppose 1/1000th of a seed is dropped. It doesn't really matter, a part of a seed or one seed. Zeno says it doesn't make a sound. A millet seed dropping to the ground doesn't make a sound. But there's going to be a ratio of seed to bushel, a single seed to a bushel full of seed. So there must be a ratio of the sound of the bushel falling to the sound of a single seed, or 1/1000th of a seed, or whatever small portion you would want. But here we have no sound whatsoever. So that means there's no ratio for the sounds, which means there is no plurality of seeds at all. Now, this one, a criticism does seem to appear, and that would be, you could have this practical concern that you might raise if you were talking with Zeno at this point. Well, wait a minute. Human ears are not perfect, right? We don't hear absolutely everything, and so maybe the seed's making a sound and we just don't hear it. And that would seem to create a problem with this particular argument. There are criticisms of the primary argument, that first argument considered going from A to B, which concluded that there is no motion. So is premise 5 true? It seemed when we got to premise 5, and you can go back in the video to make sure you know what premise 5 is, but premise 5 assumes that there's an infinite distance to traverse. Right? It's impossible to traverse an infinite distance, it said. But is there? Is there really an infinite distance to traverse? Here's one way you might form this criticism. For any finite portion, no matter how small, this would be rather Zeno's perspective, right? Zeno saying, look, it doesn't matter how small of a portion. If you're going to sum that portion indefinitely, it'll add up to an infinity. So you could start with 1/1000th. Take 1/1000th of a micrometer, which is extremely small, right? A human hair is 100 micrometers. Take 1/1000th of a micrometer. But, if that's all you had as a distance, but you had infinitely many of those, well, that would be an infinite distance. So on the one hand, it's plausible. It doesn't matter how small the distance is, you're going to end up with an infinity. However, The way we constructed the argument, the way Zeno constructed the argument, there's never going to be a smallest portion in the infinite sum. And we'll see this when we talk about Anaxagoras. He makes this point. So the sum of the series would seem to be 1/2, right? That's your initial A to C, plus 1/4, that would be your A to D. And then we keep cutting that in half, 1/8 plus 1/16 plus 1/32 and 1/64, and so on and so on. Well, what would that series add up to? Maybe you know, maybe you don't, but it adds up to 1, right? And this is a basic principle of calculus. Now, Zeno didn't know calculus. In fact, no one did for another 2,000 years, so we shouldn't blame Zeno for this. But this is one way that people have responded to the argument. Some people are not satisfied with this response whatsoever, but this is one way some people have suggested to get around Zeno's argument. There is another criticism against the no motion argument, the primary argument. And what Zeno may have meant is not that the distance itself was infinite, right? We can defend Zeno in this way. And this seems to be the way Aristotle interpreted Zeno. But there are infinite sums of distances. So the distance itself may not be infinite, but there are infinitely many of them that you would have to traverse. So that itself is a problem. That would take an infinite amount of time to do so. So this would be, a more natural interpretation maybe of Zeno's argument, and the previous criticism still would have to deal with this issue. Here's Aristotle's response, and I think Aristotle does not get enough credit. Of course, I often think that. But Aristotle argues that infinite is said in 2 different ways. He does that in the Physics, and he talks about the infinite of quantity, where you're adding things together. And he says that's one kind of infinite, but there's also this infinite of divisibility, where you're dividing something. And that's the kind of infinite Zeno is talking about. But when we're talking about infinite in divisibility, then you could say that time is infinite in divisibility also, just as space is. If space is infinite in divisibility, the way Zeno assumed, then time is also infinite in divisibility. So what you might say then is that time has this infinity of sorts, right? The infinite of divisibility, and that matches space. So to say that we don't have enough time to cover the distance actually isn't true, right? We have an infinite amount of time, if that's what we mean when we're talking about the infinite of divisibility. Well, we have that. So we have the infinity that matches the infinity of space. So it's not possible to traverse a quantitative infinite, right? A quantitatively infinite distance would be impossible to traverse. No one could possibly do that. That would take an infinite quantity of time, which cannot be actual. So Aristotle says that is not exist in actuality. But the divisibility, that would work. There's also a criticism of the argument of the arrow, and we saw a hint of that in the first criticism of the no motion argument. It seems that the argument relies on the assumption that time is composed of discrete nows, right, or instants, right? That sets up the argument. At any given time, the arrow is in that specific place at that particular time, a discrete time, call it now, right? But again, time is infinitely divisible, so maybe there is no such thing as now in the way that Zeno needs to set up the argument, right? There is no single point in time that is a now in which the arrow occupies that particular space at that particular time. There is no such thing. right? So that would undercut that argument regarding the arrow.